Right, so we're streaming live, and yeah, I'm looking at this Lorenz system. So this is something that's completely new, and I haven't done a video for absolutely ages. So I'm going to zoom in a little bit. I'll close up this sidebar. I'll keep the terminal open, I think, and I'll turn off some sounds, I guess, as well, because otherwise they'll be going on too much. And what else is there to do? I think that's kind of like it. I might zoom in a tiny bit more, but basically I should really do an overview, so maybe I'll just hit a run of this actually just to see what comes up. So I've just hit F5 to run everything. You can see that it's running down at the bottom here, showing the chart, and it's going to launch its chart, and we get this. So I've kind of like built this. It's the Lorenz Attractor. We can Google it up and have a look as well. It's actually, I think, yeah, this one is just one attractor. So it starts, I think that's the last point on it. That's probably, it starts at 0.1, I think. So that's probably the first point, something like that. So it does a little spiral around there, and it's like gets darker in time, and that's like the end point. So that's kind of, it's a chaotic motion basically. So that's kind of like what I got to, and let's just tab back. And yeah, so what I did was I had to introduce a data class at the top, and I'm using Plotly Go, so it's just a little bit nicer because it displays the actual chart. I wonder if I pull the chart back, when you hover over using Plotly, it kind of like shows here the X, Y, and Z coordinates, so it's quite nice. I wonder if the color actually changes too. It looks like the color changes with it. So the latter points are much darker. That's quite cool. But yeah, let's just go back. So what is this? This is a system that basically, it's an iterative process. And it's a chaotic system. It works in 3D space, so we've got an X coordinate, a Y coordinate, and a Z coordinate. And there's a little formula here, and these are the initial conditions. If nothing's set, this will be sort of like the default numbers that goes in if nothing's set. And basically, given an X, Y, and Z position, this function here, and it could be any sort of iterative function, but the Lorenz one's specific function follows this specific formula. So you're given this initial point, and then you compute the next point, so x dot, y dot, and z dot. So given an x gets transformed. Given an x, y, and a z, x dot, which is the next space, the next x point, is just s, which is this value, unless it's given a different value, times by y minus x. So sort of like, again, if we just look at it on here, y is the, I guess we've got two horizontal axes. One is like the width, and one is like the length, basically. So you've got an x and y, and then z is the vertical axis, so it's up in space. If we're just looking at it like that, just to agree on a system, that's kind of like what we're looking at. So the new value of x is based on the previous value of x and the previous value of y. So it's not, the new value of x isn't determined at all by the value of z. The new value of y is determined by x. It's also determined by y, and it's determined by z here. So it's determined by three things, and finally we've got z here, which is determined by y and z and x as well. So we've got this object that moves in some kind of way. Given an initial point, we get a final point that comes out. So that's sort of like all we know at this point. Now, I decided to do this in a way where, so this gets us our next point at each point in time for our one step. But we need to make a lot of these because we want to see it move like over the course of time, and where do I set the number of steps? I mean, I've got a number of steps here, number of steps here. Well, I set it at the top, yeah. So that's kind of like why I use the data class. It's nice and convenient. I've just set 1,000 steps, so it's clear. I guess, well, I did try on an original one. Let me just put in an extra 0, so now we've got like 10,000 steps in here. If I do run it, I wonder if it will take too long to compute, because it did previously. That's not bad actually. That's 10,000 steps. So that's a 10,000 step. So that's 1,000 steps. There we go. She just got more points basically. But we can see one thing. We can satisfy ourselves. This is like a bounded situation. So although it's chaotic, we don't exactly know where the points are going to move. They don't move out of the bounded zone. That's one thing that we do see. So we go, anyway, let's go back. And the other bit is our time steps. That's our computational things. We've got 10,000 increments that are each 0.01. I'm just going to move this back down to 1,000. It's just a little bit clearer. Now, what I actually wanted to do, so that's our computation for the single step. And this is our actual time series down here, function. So it's not making a plot in Plotly at the moment. This is function to compute the time series. By the way, this is all in real time, so I haven't pre-planned anything. I'm just literally doing this, and I'm going to be trying to do something slightly new. And just over there, I'm just keeping my spaces. Plot the charts, I call it that. Here's the time series. So we take this function and we just run it loads and loads of times. Here's our time step, so we increment the time step, and this is our original point, our point I, and we want to compute the next point, which is I plus 1, and this is the transformation, which is whatever the value of x, y, and z are. They go into this piece here, so that's containing the x, y, and z bit, and then we've got these extra parameters that we've set somewhere. We've chosen them. They're either going to be default values or we're going to pre-select them, but either way they're values of the system. Now we go to do the plotting of the charts, and I've set up this colors array, which is just a NumPy array, which is just the same length. It's the number of steps basically, plus, well, I put plus 1 here, so it goes from 1 to plus 1. I wonder if I could do 0. I think 0 might be allowed as well. I'll put in 0, 0 and 0, and just run that. I hit F5 to run it. I don't think that breaks anything. Yeah, perfectly fine. Okay, so I'll leave that bit of code in as well, and let's just go back. So and then do plus 0 now. It's a little bit cleaner on the code. So this is just a list of numbers. np.arrange is just a NumPy array, or NumPy list. In fact, I can hover over it. I don't know what the np thing was. That's NumPy. Okay. So it's just a list here. Return evenly spaced values within a given interval. So well, I shouldn't call it a list. I should actually call it an array, because that's what it is. It's a contiguous block of memory. So then afterwards, this is where the plot's actually done. So I'm using a fig equals go figure, so this is the Plotly go module, and this is the figure thing, and basically what goes in here is some data, and then some layout, some frames, and there's some other stuff as well. I wonder if I actually hover over it, because I've not done that as well. I kind of like just use that straight out of one of the GPTs. I either use ChatGPT, or I think I used, I don't know, Bard. Did I use Bard? I've been using Bard for other things, so I had Bard in there as well. I wonder if I can see my Bard history. Okay, so I didn't use Bard, but I did use ChatGPT. I've got a whole bunch of other stuff. So the ChatGPT's over there, and yeah, you can see like an entire thing. I've been looking it up. I could like I partly used some of the docs, and then like nowadays you can use a lot of ChatGPT and other things as well. So, oh, by the way, this book is an interesting book. It's called Stand Behind Me, The Full Life Cycle of a Quantitative Trader. So, by Professor Newton Scholes. You can get it on the Amazon bookstore. Very interesting book. But let's go back. Yeah, I was on Plotly and Python there. So, yeah, I use that and I use documentation. And let's just move back again. We put in our X, Y, and Z coordinates. This dot T is actually the transpose of it. So we've got like, I wonder if I can actually do this, which is, I wonder if I've got my drawing objects. No, I don't have it there. G-Link. Basically, I believe that we compute something like this. So these are all of the value, like 1, 2, 3, 4, 5, 6, and it's split into, so these are all of our lines there like that. This is actually when we define the array further up, and it's split into 3 bits. So it's kind of like that and that. So we created that, and we've created that. If I just scroll up a bit, I'll keep that there. We've created this in our definition here, which is number of steps plus 1. I wonder if I'm missing like one point with it. I always like have to be careful about the end points, basically, like the boundary conditions. But this is basically the number of rows. So how many rows are going to be, and this is how many items there are in each row. So that's this red matrix. And down here, what we're doing here, this is for the actual plotting of it. The X, Y, and Z, we are taking the transpose of that, which is exactly the same object, but this way, I guess. So there we go. So that there is the, I should draw in a different colour, is the transpose basically. That's the transpose operation, that's what we do. So we can pass in the X, Y, and Z. So these things feed into here. Then we've got some lines and markers. I put that, you could have just markers. I did that before, but I thought the lines would be a bit nicer. I made the markers small, so size 2. The colours, that's what this colours array is, which is from up here. So this is the actual colours array. And then I just did the set of blues. I could do like reds. I did do reds before, but the piece I'm going to do is actually I'm going to try and do blues, reds, because I'm going to fit in 2 things, and then you can give it a name. So I've called this first plot, and that's kind of like where I got to. So that is everything that we see, and that's what actually runs. So I wonder if I can actually hide it all and bring it back. That's quite cool. So anyway, I go back. Oh, and then finally, this is the actual layout. So I put a title on there, and then the X, Y, and Z axis. Now I want to do a second plot. I did print showing the chart because in other variants, like not in Windows 11, so I was doing this first in Linux. Basically, I was doing it on a Chromebook, and Plotly and Matplotlib and all the rest like work all slightly differently between different operating environments, which is a little bit annoying, to be fair. It's really annoying. because I couldn't do, for example, here I can't do fig dot show. Right, I can't do that. It doesn't work, basically. It just hangs indefinitely forever, and it was a bit annoying. But what you can do is write an HTML and then basically auto open equals true. So that's kind of like one of the conventional ways of getting around that. Then finally, this is just the this is actually the main module, and this is the if name equals main guard. We just run the main module, and what we do, so it's the main entry point for the code, is we run this make Lorenz time series function. It takes in the parameters, basically, is what it does, and spits back out some kind of ND array. And that's pretty much it. I'm just wondering one thing in there. The initial conditions are always the same. So basically, it's given a set of initial conditions, which is a starting point, basically. So the initial starting point, we don't change that. And given this S, R, and B parameter, so and those are the things that I'm going to be changing, we get this, we get a plot that comes out of it. So this here produces X, Y, Z, S, and then we plot a chart of X, Y, Z, S. But I want to get a second chart, and I have done it a different way, but it was a little bit messier. But what I want to do is actually be able to do it in like functionally, so that I can add however many charts I want to add. So this is how you plot a chart, and I wonder if I've actually got that on ChatGPT already, because I was asking that. Yeah, it's there. Where is it? It must have been somewhere here. Two labeled. Yeah, it's something like you can do an add trace, I think. Fig.add trace, fig.add trace. So I'm gonna scroll back. That was me trying to get it working and testing out labels, because I want to label them differently. So the way that you label them is with this name thing. So you can give label with this name argument in the add trace function. So the add trace function is, well, I'm not using add trace here. I'm using the scatter 3D function. Actually, quite interestingly, these are all of the bits. So I might re-look it up, although I've looked it up somewhere already. Something like, if I just take this, copy that. If I can't find it, then I'll do it. I'm just going to do it. So I'll do something like, given this code using plotly go add an extra in red, and the code will be this. I think I have to stop streaming now because there's someone at the door. That's rather annoying. But, well, I guess I'll have to come back. But where are we? We are at the point of, yeah, here we go, second scatter plot. Do we just do that? I think name equals second plot. Okay, fine. It's before it seemed a little bit more than that. Oh no, they both go in the square brackets. Yeah, so that's fine.